Alright guys, the next video here is going to be about factoring polynomials, especially when a equals 1. When I say a equals 1, it's going to be the leading coefficient. So you're going to see a variable out there without a number in front of it for these type of problems. The second part would be a separate video is when that coefficient is not equal to 1, and that's what that follows really closely along. I'm looking at page 90 in your book, and I'm looking at those type of problems. So if you wanted to flip over to page 90 in your book, you're certainly welcome to do that, or you can kind of follow along with this and then go back and try some of the things as you go. The type of questions that you're going to be looking at is these are all going to be trinomials, which means there are 3 terms. And when we look at this first one, I'm looking at the example on page 90. They are giving us x squared minus 6x plus 8. And the directions are simply to factor this. Well, you can't factor this like the last video stated where you have a greatest common factor because there's nothing that goes into x squared. There's nothing that goes into 6 and 8 and x squared. So there are no common factors to pull out. It's not that type of problem. If there were, I would do that. But since there's not, we have to think of a different way because this can be factored. Just on a side note, when you're looking for a factor of this, if as you grow and what you know and everything like that, when you graph this is going to be kind of indicated where this parabola, which would be what this graph would look like if it were written as an equation, will cross the x-axis. So factors help us find that. That's why factoring is such an important topic and what we're doing right now. When we're looking at this thing right now, there are a couple of things that have to happen. Before I do this example, which I'm going to do, I'm going to go through and show you what happens when you're adding a couple of things together, or multiplying a couple of things together. You did this type of problem the other day, where you had one set of parentheses times another set of parentheses. And what we decided was you had to do the first term times this and the second term times this. So it was really 2 multiplication problems to start with. So it's going to be x times x minus 4. That plus sign comes down. And you have 3 times x minus 4. And what that left us towards was something like this. We have to go ahead and distribute now. X squared minus 4x. 3x. 3 times negative 4 is going to be 3x minus 12. And then finally, we can put together those middle terms. So that should be a reminder of what we did the other day. The reason I did that problem is because we're going to be doing the backwards, we're going to reverse the steps of that, because if you look at that example that you've been given, example A, and what we ended up with after I did the distributive property, you end up seeing that those are pretty close to the same type of question where you have x squared, you got something in the middle, and then you got a number at the end. What I'm going to do, because this is something that can kind of be expanded to a later some later topics that you're going to be looking at, is I'm going to list all the factors of 8 to start with. So these factors of 8 are what I'm going to look at to begin with, because that's usually pretty helpful to be able to do this. So when I look at 8 right here, 1 times 8 is certainly going to equal 8. Another pair of factors for 8 are 2 and 4. When I look at it, I don't think that there are any other factors of 8. 1, 2, 4, and 8 are it. And they come in pairs like that. As I look at those two sets of pairs, 1 times 8 does equal 8. 2 times 4 does equal 8. But what I need is, I need these middle terms like I had here. These two middle terms, negative 4 and positive 3, added up to this negative 1x in the middle. I have a negative 6 in the middle. There's no way with adding or subtracting I can get an 8 and a 1 to give me a negative 6. Negative 1, negative 8, it still isn't going to work whether I add, subtract, make positive, whatever. But I can get a 2 and a 4 to have a sum of 6. I can get a negative 2 and a negative 4 to have a sum of negative 6. And that's the topic. That's what you have to look at right there. Which one of these ordered pairs, they're not ordered pairs, I said that wrong. Which one of these pairs of factors could give you that middle number right there? And the answer to that is going to be this 2 and 4. And that topic's going to be pretty important as we go forward. Notice over here, if I reverse this, I would end up with 2 sets of parentheses on the example we did over on this side. I want to end with 2 sets of parentheses now because I'm undoing what we did before. So I'm going to have a set of parentheses here with x at the beginning of both of them, just like I had over here. I know that's appropriate to have because I have right here x times x gives me x squared if I looked at no other part of the problem. I need these last numbers to be factors of 8 because whatever I have at the last number here and here is going to have to multiply up to 8. But I need them to add up to negative 6. And the only way to make that happen is to make this a negative 2 and a negative 4. Now, that's factored completely, and that example is done. I know it's right, because if I multiplied it back out, I would end up with what I did on the other side, x squared minus 6x plus 8. So that's how I know that my answer is right. I can still multiply it out at the end, which is going to be a way to check, self-check those type of things. Look at another one here. Your example B on that type of question was when we look at x squared plus 9x plus 8. I don't like that they had 8 for all of those, but that's okay. When I look at 8, the factors of this last number are 1 and 8, and 2 and 4 again. Well, when I look at this one, 2 and 4 can't add up or subtract or anything like that to give me a 9, but 1 and 8 can. So I'm going to have these two sets of parentheses. When I factor trinomials, I end up with that a lot. The x times x, that's how I'm going to factor out x squared. And then in order to make that 9 and 8, we got x plus 8 and x plus 1. And then I'm done. I can multiply back out to check out. If I did, the product of that would be x squared plus 9x plus 8. The last one that they have up there is a little bit more tricky, I think. So when we look at this one, we've got x squared plus 4x plus 8. And this is a pretty common misconception that people would have. I'm listing the factors of 8 because the last number for all three of these examples is 8. I cannot add or subtract 1 and 8 to get a 4. And for that reason, I can't use this. I can't add or subtract a 2 and a 4 together to give me a 4. I could get negative 6, I could get negative 2 or positive 2 or positive 6, depending on where I put plus and minus sign. But there's no way to get a 4 in the middle there. So when I look at that particular question right there, what that's telling me is this cannot be factored, and it's totally okay to have one of those things right there where it cannot be factored. If you've tried it and you end up eliminating all the possibilities and you're not getting it, it's perfectly reasonable to say it cannot be factored. So the simplest form of that would be just x squared plus 4x plus 8. The next thing we're going to look at is some of the other ones, like if we have a negative number at the end, because it gets a little more tricky then. So I'm going to do those example 3 down there. When you look at example 3, the reason that one kind of stands out as a little bit different is that it has a minus 12 at the end. So when I look at x squared plus 4x minus 12, there's a couple ways to do that. I can list all the factors of 12, which is what I'm going to do for this. So 1 times 12 gives me 12, all the possibilities. 2 times 6 gives you 12, or 3 times 4 gives you 12. So there's 3 possibilities. 12 makes it a little more likely that I have to check some things. The fact that there's a negative 12 there means that when I do this, I'm going to have an x plus and an x minus here when I do my factoring. The reason that is because one of the first topics you were learning about was when you multiply a negative and a positive, you get a negative. That's the only way you can get a negative 12, is if those last numbers have different signs, positive and negative. So when I look at these numbers right here, 1 and 12 cannot give you a 4 in the middle. 2 and 6 can give you a 4 in the middle. 3 and 4 can't give you a 4 in the middle when I'm talking about adding and subtracting. So I'm going to have to look at 2 and 6. When I look at that, I already said that one of them is going to have to be minus and one's going to have to be plus. And the way we can figure that out is we can put a 2 and a 6 here because I know I can get a 4 out of that. I just got to figure out which way it is. If I wanted a positive 4 there, I need the 6 to be the bigger one. The more positive one, I'm sorry, because it's a bigger number. If that was a minus 4, I would put a minus sign in front of the 6. But because it's like this, a positive 6 and a minus 2. So my factors would be x minus 2 and x plus 6. When you look at the next one here that they give, the fact that there's a minus x in the middle can throw people off at times, but it's a minus 1x. So if you want to throw that in there, you can certainly do that, and that's totally okay to do, that you don't have to worry about that then. It also narrows down the options pretty quick. These are 11 apart, or you can get 11s or 13s if you add or subtract these numbers. You can get 4s or 8s if you add or subtract those. You can get 7s or 1s with this one, so it's got to be that one if it can be factored. That number in the middle is a negative, which means the 4 is going to have to be the minus sign in this case. So x minus 4 and x plus 3 would be the way to have to factor that. It should look familiar from Algebra 2 for most of you guys. Again, you can multiply that out and get x squared minus x minus 12 to check your work. Finally, we have this last one on example 3 that says x squared plus 2x minus 12. Again, it's a 12, it's minus, I get that. It's kind of repetitive at this point. The problems that you do are not going to be that way. When I look at these are either going to give me a 13 or an 11, not a 2. I need a 2 in the middle. That's the key number now. 8 or 4, nope. 1 or 7, nope. I've eliminated all the possibilities because I have to use factors of 12. I can't get a 2 with the factors of 12. So this one will be another one where it cannot be factored. And there's not a quick way to do that other than to run through the options and the possibilities to see if that will work, and you can kind of look at that idea right there. Your book uses a chart to kind of do what I just did verbally. I'm not a big fan of using the chart, but if that's something that helps you to stay organized, certainly you can go ahead and use that. That wouldn't be a problem. So again, my steps, I'm going to write this out like this because it kind of works for everything. The first thing you would do is you would, I said fine, but you would list the factors of C. That's going to be the number without the X. Secondly, you're going to find the combination of the listed factors that have a sum or difference, add or subtract. Of B, that middle term. And then you can go from there and use that template where you're looking at the sets of parentheses. So always start by listing the factors of that constant term at the end. Negative 12 in this case, or 8 in the other case, whatever it happens to be at the end of the question. Then figure out which one of those combinations give you B, that number in the middle right in front of X. Because there's not a factor out front, not a number, a coefficient for X squared, you don't have to worry about the idea that you would have to multiply some things. That's going to be the next lesson. So if we can get this down and make sure that we are proficient at this to start with, we mastered this concept, then it's going to make the next one a lot easier to do. So we don't have to do as much guess and check when that's necessary. Hopefully this helped you guys understand things a little bit better, and you can understand what's going on with your homework assignment. The homework assignment that you guys are going to have for tonight is on page 95 in your MCCR book, and you're going to be looking at the ones that kind of questions that we had right there, 19 through 34. Like I said, hopefully those work out and we can get that all straightened out as the days move forward. So thanks for watching.